Alright, algebra class, we're going to be doing domain and range of graphs. Now this is pretty complicated, so make sure you're paying attention. You kind of have a little bit to do on your homework last night, and you'll have a little bit more to do tomorrow. Alright, here we have a graph, an XY coordinate plane, and you see the green graph. That green graph is actually called a linear graph because it creates a line. Now we want to find the domain and range of that line. So remember, domain is x, and we want to figure out what x values are on that line, that contain that line. And this is the best way I can represent this. X is like a ruler. This is a ruler right here. And we're going to measure this green line. Now, what do these arrows mean right here? That means it goes on forever to the right and forever to the left. Now, they kind of go in a diagonal, and that's fine, but it really goes on forever to the right and forever to the left. So, the best way I can tell you to do this is if, picture it this way. Can I take this graph right here and turn it to where it actually lays on the x-axis? Now, how many x values does it cover? It covers all of them because it goes forever left and forever right. It covers all the negatives and all the positives. So the domain for this one aren't actual values because it even contains all the fractions that are between 0 and 1. So it contains everything. So what do we write for that? We write that the domain is all real numbers. Now the range is the same way. It's like if we took the graph and we put it on the y value. It would cover all the y values up and all the y values down. So we put that the range is all real numbers. And that's pretty much it for this graph. It's that easy. It's not anything hard. So let's go on to another graph. Alright, here's another graph. Now, this one's a little bit more difficult because there's curves in it. Let's focus on the domain first. Domain. Domain. What does the domain represent? So it's like if I took this graph and I laid it down on the x-axis. It means it goes from here to here. And what are those values for x? Well, this one is -1, -2, -3, -4, -5. And this value is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this purple line is continuous. Remember what continuous means. It has an infinite amount of solutions in there. It contains all the values from -5 to 9. Now, we have to write that in mathematical terms. How do you write something that's between -5 and 9 and contains all the values? We did it not too long ago. Oh, how about using a compound inequality? How about actually writing that x is between -5 and 9? Now, we can't actually write that because that just says -5 times 9. That doesn't make sense. We want to say that -5 is x is between -5 and 9. So, what is x? Is x bigger than -5 or smaller than -5? It's bigger than. And it also can equal -5. And x is also less than or equal to 9. It's kind of like if we took this graph right here, and we made it into an actual inequality graph. So in other words, when I squished it down to here, I put my dot here, fill it in, I put my dot here and fill it in. The purple goes away and I fill everything in between. How would you write this as an inequality? And that's what we're doing. That's all we're doing. We're writing it as an inequality. But you've got to do it without doing that. But that's what you need to look at. So here we have the domain is between -5 and 9. So let's do the range now. Range. All right, so we're going to do the same thing with y. I'm going to take this dot and go straight across to the y-axis, fill my dot in, go straight across to the y-axis, put my dot in. I'm going to erase that, and I'm going to fill in everything in between. And I'm going to write that as an inequality. This is -2, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So my range, y, goes from -2 to 9. And I write it as inequality. And that's all we're doing. We're just writing it as an inequality. Here, let's do another one. Here we have a really awful looking oval. And we want to find the domain and range of this oval. Here's my domain. Here's my range. Okay, so let's see. I'm going to figure out x first, domain. So this one's actually pretty much done for me. Here's my value. Here's a value that's as far as it goes left and far as it goes right. At 3 and -3. So if I fill in from both of those, I'm going to write an inequality for that. It goes from -3 to 3. Here's my x. It's greater than or equal to -3 and less than or equal to 3. Now let's do range. Goes to here and here. I fill everything in between, which it goes from -5 to 5. So I have -5y and 5. That's all there is to it. You're done. That's the domain and range. That lists all the values between -3 and 3. All the possible ones, because it's really impossible for us to write every possible number between -3 and 3. We'd be here for the rest of our lives. So we write it this way to make it simpler. Let's do another one. Last one. All right, let's do this one real fast. Domain and range. Domain is x, so let's check out x first. This one goes to here, but you notice how this hole is open, this point is open. So it's just like an inequality, it doesn't equal that point. So I'm going to put a circle here. 1, 2, 3, 4, 5, 6, that's -7. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one actually already has a point. So I'm going to fill everything in between. So my domain for this one is -7x and 9. X is bigger than or equal to -7? Nope, it's not equal to. It's just bigger than -7 because this is not filled in. But it is less than or equal to 9. You see the difference? Now let's do the y. Y I'm going to go over. So here's a point for y, and here's the tallest point for y. It doesn't have to be actually at the points. It just has to be the tallest point where the graph goes up. How far does it go up? How far does it go down? So let's see. 1, 2, 3, 4, 5, 6. and 1, 2, 3, 4, negative 4. So my range is negative 4 and 6, and they're both, this one's going to be greater than negative 4, and this one's going to be less than or equal to 6 because it contains it. This one has a hole in it. All right? And that's pretty much it. Oh, let's do one more. I promise you this is the last one. Let's do one that looks like this. And I'll graph it really fast, just so you know. All right. What if we have one that looks like this? The domain is the x. Now these arrows, even though they look like they're going straight up, they're actually going this way and this way. So they're going forever to the left and forever to the right. So it's containing all the x values to the left and all of them to the right. That's what those arrows mean. So what do we put? It contains all real numbers. Wow. All right. Now the range. The range goes forever up. So if I was going to write an equality for this, this is what it would look like. Here's where we start, and it goes this way. And how would I represent that as an inequality? It's not compound anymore because we're just going up. So that means that y is bigger than or equal to 1, 2, 3, 4, negative 5. And that's all you would write. All right, guys. See y'all tomorrow. That's it, folks.